Good afternoon, guys. How are you today? So I want to go over the notes and get this up in Schoology. So I'm going to just go over a reminder or a refresher from yesterday. We covered the greatest common factor. So the factor or the greatest common factor is basically like what number or what factor do all the other numbers that we're looking at have in common? So what we want to see is what is 12, 20, and 24? What numbers can we multiply together to get those numbers? Or what number do they have all in common? So if we look at 12, let me see. Let's start with 12. So what are the factors that make up 12? What are the things we multiply together to get 12? Well, if I multiply 6 times 2, that's going to be 12. But 6 is a compound number. That means I can still multiply two other numbers together to get 6. So I can multiply 3 times 2, that gives me 6. So at the end of the day, if I have 3 times 2 is 6, times 1 more 2 is 12. These numbers are called the prime factors. Okay, they are the smallest numbers that we can multiply together to get 12. So let's take a look at the prime factors of 20. So what numbers can I multiply together to get 20? Okay, well, I can multiply 5 times 4. Let me see if I get it. There we go. 5 times 4, that equals 20. But then 5, I can't multiply any other numbers together to get 5. So I'm just going to bring it down. I'm just going to bring that 5 down over here. Okay. 4, I can multiply 2 times 2 to get 4. So I get 2 times 2. So now we see that these are the prime factors for 20. These are the prime factors of 20. Let's take a look at the last example, and let's take a look and say, what number can we multiply together to get 24? What are the factors of 24? Well, we've got 6 times 4. That equals 24. But both 6 and 4 are compound numbers, which means we can still multiply two other numbers together to get that. So 3 times 2 is 6, and then 4, we can break it down into 2 times 2. That equals 4. So now we can take a look down here and say these are all the prime factors of 24. These are all the prime numbers that we can multiply together to get 24. What we need to do now is take a look at all of these factors and say, okay, one of the factors is 3. Do we have a 3 in common with the other numbers? No, there's no 3 in 20. Okay, there's no 3 in 20, but there is a 3 in 24. So since 3 is not common in all of the numbers we're comparing, we're not going to use that. Now, how about 2? Well, there's a 2 and another 2. Let's see, we've got two 2's. The prime factors of 20, we also have two 2's. And the prime factors of 24 also have two 2's. We've got this extra 2 in 24, but we at least have 2 in common for each of these numbers. And because we have at least 2 in common in each number, that means our factor in common, or our greatest common factor, is 2 times 2. 2 times 2, 2 times 2. Okay. We're not going to worry about the other numbers that aren't included in the prime factors, right? We're not going to worry about this extra 2. We're not going to worry about this 5. We're just going to worry about the ones that are common. Oops. We're just going to worry about the ones that are common, which means 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. So we're going to say our greatest common factor for 12, 20, and 24 is 4. The other way to think about this is to think like, what number can I divide all the other numbers by evenly without having a decimal or a remainder? So I can definitely divide 12 by 24. 12 by 4, which equals 3. I can divide 20 by 4, which equals 5. And I can divide 24 by 4, which equals 6. Now, can I look back and say, can I divide by a bigger number evenly? So like, could I divide 12 by 5 without getting a decimal? No, 12 divided by 5 is a decimal. Could I divide 12 by 6? Yes. But can I divide 20 by 6? No, I can't, so it can't be 6. How about 7? Can I divide 12 by 7 without getting the decimal? No, and 8 and 9 and 10, so forth. If I keep trying bigger numbers, I'm not going to be able to divide all three of these numbers by a bigger number than 4. So that's why 4 is our greatest common factor. Okay, now let's take a look at some examples with some numbers and understand what we're going to use the greatest common factor for. We're going to find the GCF in order to factor polynomials. So we're going to use the GCF to factor polynomials. The first thing we need to do is divide by the greatest common factor. And in order to divide, well, we need to figure out what this is. So we need to find the GCF so we can divide by it. And then the second step is we're going to write the GCF, then the remaining factors in parentheses. So what that means is once we find the GCF, we're going to write the GCF and then parentheses, and inside there are going to be some numbers here, plus or minus, and then something else here. That's the form that our GCF is going to look like, or our factors, in order to write the factors. Okay, it's going to look like that. So now I'm going to make this a little bit bigger so we can see. Let's take a look at this first example. 51x squared minus 17x. I need to find the GCF, which means the biggest number that goes into both of these terms. And then I need to divide by it so I can find the factors. So before I do that, I want to rewrite this expression in a different way. Like I want to write it in the expanded way. So instead of x squared, I'm going to write 51 is x times x. Okay, it's the same thing. I'm just rewriting it. X squared is the same as writing x times x. And remember, 51 is being right here is there's a multiplication between the 51 and the x. Okay. Now on this side, I've got the minus sign, and then I've got a 17 times 1x. So now I can go back and look and see what number goes into 51 and 17. This one I actually had to use my phone and trial and error a couple times. So I did 17 times 1. It took me a while. So I did 17 times 1, which equals 17. Then I did 17 times 2, which equals 34. And then I did 17 times 3 and got 51. Okay, so it took me a trial and error a couple times to figure out that 51 is divisible by 17, and 17 is also divisible by 17. So, like I said, you may have to trial and error a couple times or use a calculator to figure out that part. So basically, I can divide both sides by 17, and I'll get an even number without any remainders or decimals. Now, as far as the x's go, how many x's do I have here? I have 1, 2 x's, and here I only have 1. So the maximum number, or the number that they have in common, is 1x. So I'm going to write that down here. When I'm writing the GCF, or I'm dividing, both of these numbers have to be exactly the same. Whatever I have on one, I should have on the other. So these need to be the same. Now what I want to do is remember this right here, what I'm dividing by, that's actually my GCF. That's the greatest common factor. So I'm going to rewrite that 17x. Then I'm going to draw parentheses. And what goes inside the parentheses is all of this, like the answer from 51x squared divided by 17x squared goes here. I bring down the minus, and then the result of this is going to go right here. Okay. So 51 divided by 17, I said, is 3. I know that's 3 because I tried it out. Now this x right here cancels one of these x's. So I could say that x cancels with that, and what do I have left? An x. And then this, so I have to remember that anything over itself equals 1. Doesn't matter if I have x divided by x. If I have 100 divided by 100, that's going to equal 1. Anything over itself always equals 1. Okay? And because we remember that, now we can look and see 17x divided by 17x means we're going to have a 1 there. So that means our factors are 17x times 3x minus 1. Okay, let's take a look at the next example. I've got 9y squared plus 18y to the fourth. I want to do the same thing. I want to find the greatest common factor that goes into both of these terms evenly. So looking at 9 and looking at 18, I know that I can divide both by 9. And as far as the y's, how many y's do I have on this side? Well, I have 2 y's, like y times y. And on this side, how many y's do I have? I have y times y times y times y. It's like 4 y's. So I can see that I have at least 2 here that can pair up with 2 from this side. So under here, I'm going to write 2y to the power of 2, 9y to the power of 2. Remember, this number that we're dividing by, that's my greatest common factor, or the GCF. I need to write that down here. And what goes first is I'm going to do this division. So 9 divided by 9 is 1. Y squared divided by 9 squared is 1. So 1 times 1 is just 1. The other way to look at it is 9y squared divided by itself is always going to equal 1. I bring down the plus sign, and then now I'm going to look at 18y to the fourth divided by y to the ninth, and that's what's going to go here. So 18 divided by 9 is 2. So I'm going to do the coefficients first and then the variables. Y to the fourth divided by y squared. Remember the quotient rule. I want you guys to write this off to the side here, somewhere in your notebook. The quotient rule says that if you have any number raised to an exponent divided by the same number raised to another exponent, the answer is going to be the base to the power of the top minus the bottom. So an example would be like, let's take a look at this. This is the quotient rule. It's important to remember this when you're trying to find factors. We're going to say, let's use this as an example. Y raised to the fourth power divided by y raised to the second is going to be the top minus the bottom. And 4 minus 2 is 2, so it's going to be y squared is the answer. So right here, we're going to have 2y squared. So now this is our factor. We're going to use these factors later on, but let me show you what we're doing here. If I multiply 9 times 1, 9y squared times 1, I'm going to get 9y squared. If I multiply 9y squared times 2y squared, I'm going to get 18y to the fourth, which is what we started off with. So we're not really solving anything. We're just finding a different way to write it, because later we're going to use this and this to find something else. So we want to get it in this form. That's all we're doing here. We're just writing things in a different form. So now let's take a look at this one. This one's kind of tough, okay? I want to find the common factor between 77 times j to the power of 2 times k to the power of 5 minus 44 times j to the power of 5 times k to the power of 2. What is the common factor? Well, I have to remember that my multiples of 11 times 1 equals 11. 11 times 2 equals 22. 11 times 3 equals 33. So see the pattern? Anytime I multiply a number times 11, I'm going to get double digits of the same number. So I should recognize that 77 and 44 have a kind of a pattern to them, and I can divide both by 11 evenly without having a remainder. The next part is tricky. I got to figure out how many j's do I have in common with both terms. So here I've got 2 j's. And how many j's do I have over here? Well, I've got 5, which means what's common to both terms? Well, I can only pull out 2 j's. So I'm going to write j to the power of 2. Now let's take a look at the k's. So see, I just went in order. I looked at the coefficients first, then the first variable, then the second variable. So I've got 5 k's here, and I've only got 2 k's there, which means the most k's I can pull out is 2 k's. I forgot to add the j square. Remember, whatever I write on one, I have to write on the second one. So now I can only pull out 2 k's here. So I'm going to write k to the power of 2, k to the power of 2. This means that 11j squared times k squared, this is my GCF. J squared times k squared is my GCF. And inside the parentheses, remember, I'm going to do this division, 77j squared times k5 divided by 11j squared times k to the squared. That's going to go here, and then the answer for this is going to go here, and I have a negative in between. Okay, so let's figure this out. Let's see if we can figure this out. Let's start with the first one. So remember, 77 divided by 11. Oops, let me undo that. 77 divided by 11 is 7. Now, j's, I've got 2 j's here. That cancels out those 2 j's. And then I've got 2 k's here. That's going to cancel out 2 of those, but I'll still have 3 left. So I started with 5. I'm going to cancel 2. I'll have 3 left. So that means I've got a k to the power of 3. Now on the second one, 44 and 11, 44 divided by 11 is 4. I have 2 j's down here, which will cancel 2 up here. I'll have 3 left. And then this k is 2, and there's 2 k's there, which will cancel out. So what I have left is this j to the power of 3. And that's it. So my final answer, it's not really my answer, these are just my factors. My factors are going to be 11j squared times k squared, and this part is my GCF, times 7k to the power of 3 minus 4j to the power of 3. Now if I wanted to check my work, I could do that by distributing this here to multiply all of these things together. 11j squared times k squared times 7 is 77j squared times k to the 5th minus 11 times 4 is 44, j to the 5th times k squared. And you can see that's what we started off with. So we must have done our work correctly because we were able to get back what we started with. Okay, so what I want you guys to do for the class today is you're going to work on number 4, and then you're going to work on 5 and 6. Once you're finished with those, we're going to go over 7 and 8. I want you to try to work on those today in class.